we're not done with Pascal yet. He has this principle that got him the unit of pressure named after him. So here we have a tube that has a changing radius. So this side over here has some area A1, and this side over here has some area A2. Now let's plug this thing out. Let's fill it up with a fluid. Let's pick it with like some sort of purple fluid here. All right, so it goes through here, and then it kind of comes out like that. So there's a whole bunch more over here. But now let's plug them. We're going to stick something in there. Let's stick it. This green plug looking thing here. All right. Now, at the same height over here, I've got this side plugged up. Let's see if I can do this. Nah, I can't. All right. So, my pressure here at part 1 has got to be the pressure over here at the same time because they're at the same height. So the pressure over here at 1 has to equal the pressure over here at 2. But now what happens if I push on one of these sides? So I'm actually going to push down this way with some force 1. But it's not going to move because we're still into statics. So it stays here. I've got this force 1 over here at A1, but I'm not moving, so I'm at the same height. Pressure 2 has to equal pressure 1. So what that means, because I'm moving horizontally, pressure 1, pressure is force over area. So this is force 1 now over here, over area 1 is going to equal force 2 over area 2. So this pressure changes everywhere throughout, and that is Pascal's principle, that any change in pressure of an enclosed fluid is transmitted undiminished to all parts of the fluid and the enclosing walls. So if I want to find out, if I'm pushing this one down, this one's going to get pushed up. So here we go. So I'm going to have some F2. If I want to find out what F2 is, I'm just going to do a little bit of math here. So now F2 becomes the ratio of the areas times F1. Notice A2 is much larger than A1, so my force is larger. This is the fluid equivalent of a lever. It's a fluid lever. So now I can do small force over here and get large force out of here. Now granted, the conservation of energy still comes into play, so I have to do a lot. The amount of work is the same, so if I have a large force, I'm going to have to move a large distance. This is going to have to move a small distance. Wait.